Okay, in this video I'm going to graph the inequality y is greater than 5 times open absolute value x, close absolute value plus 3. Okay, so the first thing I need to do to graph an absolute value equation or inequality is to identify the vertex. Now the vertex has two components. It has an x component and a y component. Okay, so I'm looking for the x component and the y component. Now the x component is determined by this number that's being added or subtracted to this x, and I want to use the opposite of that number. So if inside here I had y equals, let's say, absolute value x minus 3, then the x component would be positive 3. On the other hand, if instead of minus 3 I had something like plus 4, the x component would be negative 4. But in this case, I don't have either one of those. What I really have going on here is nothing being added to the x. In fact, absolute value x is the same thing as absolute value of open absolute value x plus 0 closed absolute value, because this is just x. So my x component for this example, the x component of the vertex will be 0. Now my y component is determined of the vertex is determined totally by this value here. And whatever the sign of this value is, it's the same here. So whatever you add to the absolute value portion of the equation or inequality is the y component. So in this case, we're adding a 3. So I'm going to go ahead and plot the vertex. That's 0, 3. Now, to find out where to go next, I need to look at the a. The a determines the slope of the ray to the right of the vertex and the slope of the ray to the left of the vertex. So a is 5, so that means as I go to the right, the slope is going to be positive 5. So I need to go up 5 over 1, because remember, 5 is the same thing as 5 over 1. So up 5, 1, 2, 3, 4, 5, right 1. And you would continue this on. To get the left-hand branch, I use the slope of negative 5, which means I'm still going to go up 5. 1, 2, 3, 4, 5. Only this time I'm going to go left 1. Okay, I need to connect these points. And I notice that this is strictly greater than, so it's not greater than or equal to. So this line that connects these points needs to be dotted. So I'm going to draw a dotted line here. It's supposed to be a straight line. I realize it's not exactly perfect. Dotted line there, and I'm almost finished. I just have one more thing I need to do. I need to shade this graph. Its y is greater than this absolute value expression, so I need to shade above. So I'll pick a different color. So I start at any part on the graph and look at where above that point would be. So above this point is all this up here, right? So this is the region I need to shade. This is the region above the graph, above the vertex. Okay, so the portion that I'm shading are the actual solutions to the inequality. Notice that the dotted line is not actually a solution. None of the points on this dotted line are a solution because they're not greater than. Because it says it's strictly greater than, not greater than or equal to. So let's try to identify which points are solutions. I'll start with 0, 3, and I'll try to plot that in red. Let's see here. 0, 3. 0, 3 is the vertex. Now remember, the vertex is on the dotted line. So 0, 3 in this case is not a solution because it's not actually in the shaded region. Let's look at 1, 8. 1, 8 is again on the dotted line. If this is a solid line, 1, 8 would be a solution, but it's a dotted line, so it's not a solution. Okay, 0, 6. 0, 6. It's right here. That's in the shaded region. This one's actually a solution, so we found one solution. What about 3, 1? 3, 1 is not in the shaded region. This is not a solution. So if we want to identify a few more solutions, another solution would be, let's see, 0, 7, that's a solution. Let's change colors here. 0, 7 is a solution. We don't just have to have 0 as the x component. A 1, 9, right here, 1, 9 is a solution. Another solution could be 1, 10, right here. Pretty much any point that's going to be in the shaded region as this graph continues on forever will be a solution to the inequality.